Hello everyone, welcome to the second session. In this section we will give an overview of Lean and these are the topics to be covered. First session we will talk a little bit about the history of Lean and Lean construction and then move on to key Lean concepts where we will cover what is waste, things like value stream, push, pull, variability, which are the classic concepts in Lean. We will then Professor Raghavan will talk a little bit about continuous improvement, collaborative working, project as a production system and Lean culture as also important concepts in the practice of Lean, specifically also with respect to the construction and Lean construction requirements. We will then go on to the tools which we will cover in this session, or not in this session, in this module actually. I will cover the tools of productivity measurement systems, work sampling, value stream mapping and process charts. Professor Raghavan will cover and give you an overview of 5S, collaborative planning or the last planner system and the big room approach. Okay. Starting with the history, if we look at Lean and other management philosophies, there is a timeline on which this has occurred. Now, we are aware the Toyota production system formed the basis for Lean and Lean concepts, and the TPS had its initiation between the 50s and 60s in Japan. Now, if we go back in time, the first kind of documented aspects of management is when Whitney was credited with the use of interchangeable parts for muskets. So it said that he had a contract to produce a large number of muskets for the US government, and by using interchangeable parts, he made the productivity much better. So Whitney incidentally is also the person who brought in automation for cotton processing. Now, as we move past that period, there is a period in which a lot of formal management science started evolving. Frederick Taylor, who we see here, is credited as the father of management science, and you can see several of the terms he used, whether it's standardized work or time studies, all of this are also relevant today. But it's actually Frank and Lillian Gilbert who actually made this standardized of motion study and process charts, what was very scientifically done in as early as 1911. Since then, there has been a lot of evolution, and you would say that kind of, whether we look at Henry Ford and the assembly lines, and when we look at Lean, we look at the start of the total quality management or the statistical quality control, whether it was Deming or whether it was Sheward before Deming, or whether it was people like Ochi, all of them started bringing this in a formal way into production systems, and in many ways it led to the development of what Toyota viewed as the Toyota production system. And as we move, we have definitely moving further along, we had things like theory of constraints coming from Goldratt, TQM being formalized, the ISO 9000 standards, and as we came into the 90s, this is when Lean started getting formalized, or the term Lean was coined at MIT, and this book, The Machines That Changed the World by Womack and Jones became very popular, and Lean thinking started propagating from there. Based on the Toyota production system, very, very strongly based on the Toyota production system, but Lean and its terminologies started taking root from the late 1980s to 1990s and onward. And as we go forward, there is definitely progress, and it continues to progress the way we think, the way we bring in new tools, the way we automate, but concepts generally have remained the same. Now, when we go back to the Toyota production system, if in any reference material will talk about the 14 management principles which were propagated by the Toyota way, and if we look, these management principles are classified as 4 P's, that is philosophy, process, people and partners, and problem solving. And the 14 principles are classified in these categories, and the first principle of philosophy basically says you need a long-term philosophy. Lean is not about the short term, it's about long term. Even the TPS, nothing is a quick fix. You need to think about it, you need to implement, you need to measure, you need to expect benefits in the long term. When we look at process, these are the other principles on process. We talk about flow, which we will cover again in this course. We talk about pull systems, leveling the workload, the culture to stop and fix problems, which is also very important and sometimes very challenging to do in a regular organization, the need to standardize tasks, have visual controls, which is very relevant in construction, and use thoroughly tested technologies. So these are part of the process elements of the Toyota production system. When we go to people, the people issue is also extremely important. Talks about growing leaders, development of people and team, developing partners and suppliers. And these are also very, very core elements which make an organization successful. And finally, we have the problem solving, where we say, whether it's the go and see, or the Gemba as we call it, go see for yourself. Then make decision by consensus. And the Japanese, the way the Toyota production system said, slowly by consensus, but it's a consensus that's important. And then be a learning organization, which is the ultimate objective. Be a constantly innovating organization. Keep looking at ways to improve. Let the improvement requirement not come just from the top management, but from everybody in the organization. That's what is a learning organization. So while these 14 management principles form the basis of Lean, when Womack and Jones wrote their book, they actually simplified Lean into these core 5 principles, which were identify value, map value stream, create flow, establish pull, and pursuit of perfection. So in many ways, we will look at this and look at these principles and kind of take our concepts and tools we are learning around these. Now, in addition to this, we have to understand that if you wanted a definition for Lean, it is basically to maximize value while minimizing waste. So while the principles here don't explicitly talk about waste, minimizing waste is embedded in all of this.